Okay. We should be almost live. There it is. There it is. Okay, so my mic is on. Let's get rid of this screen. Pop out the chat. Bring that over. I don't want to see myself twice. Or at all. I tried live streaming yesterday, but I don't know, something was going wonky with my internet or XSplit. That's what I used to actually broadcast, and actually right now I just needed to re-authenticate my key, my XSplit key. I'm just gonna go to my live dashboard. I hate this new actual studio. I always go to the classic. Okay, so let's see if I go over here to live and then I stop that because I don't want to see myself. Okay. Yeah, so yesterday I tried live streaming. It didn't work too well, but that's okay. So today I have I need to upgrade a bunch of cameras. Their firmware needs to be updated. I have about 30 of them. I'm doing a job, actual camera job. There's about 30 dome cameras, 10 of these turret cameras, and then 2 PTZ cameras. And you can see my cat right there licking herself. Dolores, hey. Okay, she's not going to listen. She's a cat. So I need to update those. Right now, this place is a bit of a mess. I'll show you. There's a bunch of cameras right here. Not a ton. That's just a few of the cameras. And then I have my another 8-port Unifi switch there, which isn't actually adopted yet into my network. So we're going to have to do that. That 8-port switch only has 4 PoE ports. I have another 8-port switch that we could use. I just don't know how many patch cables I actually have. 192. So the updating of the actual firmware is going to take a bit of time. I need to figure out a way to automate it so that I don't need to actually do it every time. Whoops. Where did the chat go? Let's pop that out. All right, let me log into Unifi. We're going to get this switch adopted into my network. It was actually a switch for a client, but then they actually have their network managed by another provider, and they wouldn't do any configurations to make their Cisco switches trunk links. So we had to refigure out the actual switch. Okay, so right now we have 2 switches connected, which is this PoE. So I guess I'll name that PoE 1. PoE 1, save, and now we have to get another cable to. How am I going to want to do this? You know what? I'm going to use the first port on this PoE switch and connect it to my second PoE switch. And hopefully we can get it to adopt fairly easily. I think I'm going to have to actually invest in a 48-port PoE switch. Yeah, it just makes it a lot easier when you're deploying a bunch of cameras to plug them all in at once, grab their IP addresses, and update their firmware and change any settings that you need to change. Okay, so this is pending adoption. It may be managed by others right now. We'll see. It may fail and then ask for a username and password. seems to be going all right. Then I need to find a, I think I have a bag full of patch cables back here actually. Hey, what are you doing, cat? So I do have a bag of patch cables. 1-footers and I think 2-footers. That's just, yeah, so these are just SafeNet Cat 6 patch cables. So we could use those to actually plug into our PoE switch. Okay, is this pending an upgrade? The device is not connect. Okay, so that should resolve itself shortly, I hope. Learn more about the stun. Okay, which is fine. I believe I have that actually in my port forwarding settings. Internet gateway. Oh, maybe I don't. 3478. Well, let's do a power cycle of it. Can we actually reboot it right from the controller? Provision, forget, custom upgrade. Is there no reboot option? Manage device. Okay, let's forget it and then try to rejoin it. And hopefully that error goes away. Okay, I'm gonna unplug it from the... Actually, let's plug it into my 24 port switch. Crap. Plug it into port 3. All right. And that just plugged in. So we should be able to see that come up shortly. Hopefully it didn't go to another site. We do a scan of the network and then try to find it. And then actually do a, oh, I won't be able to do that in screen because you guys will be able to see my public IP address. Why is this not coming back up? You know what? Let's go to the Unifi. Oh, what the heck? That was weird. We'll go to the Unifi Cloud Access Portal. And we should be able to go to devices and then scan for devices. Okay. So that's a different way to actually find... Okay. And now it's pending adoption here anyway. So we'll adopt. Oh, wait. My camera's really big, isn't it? There we go. So it's provisioning, and hopefully we don't get that same error. If we do, we are going to have to just try to figure that out after. I actually used to use this a lot, and now to go to devices and then actually set them to do the set inform command back to my controller. I rarely use it now unless I'm having issues. Okay, so this is still having issues. I'm gonna have to figure that out later. But let's switch the name of it to Mac Telecom PoE. Whoops. So we should be able to plug in some cameras into this, and it should plug or actually power up. Oh, okay. So now the error went away. Perfect. Oops. So I'm going to take out a few of these 2-foot cables and plug it into the ports. All right, so I'll plug this one in. And I'll just plug in 2 for now, and then we'll update 2. I'm going to be making a video on actually how to do the firmware updates. Is for some reason on Chrome, even if you have the plugin, it doesn't show all the settings. So you have to do it through the Internet Explorer plugin or extension or the actual IE itself. Let's see if this camera works. Yep, that camera works. The turret. I was at customers yesterday and they said the turret camera wasn't working. They wanted it switched out for a bullet. So I put the bullet in, but I haven't checked if the turret works or not. But it looks like the infrared, the IR blaster came off or turned on. So let's go ahead and use the SADP tool. Okay, so there's 2. This one right here, I believe that is the XD. I'm not sure what that is. That must be the turret. So let's unbind. Oops. Let's see if we could actually access it. I don't remember if I know the username and password. Enable DHCP, admin password. Let's hope it's not that, but it could be. Okay. Okay, so we figured out the password, which is always a good step. And then we're going to enable DHCP. We'll modify it. We'll refresh, and that should go to a .1 something address. Okay, so it's 192.168.1.136. 136. Ooh. And this is our main interface, so we got to put in our username and password. Yeah, so the camera works. See right here, I'm using Chrome right now, but there's not a lot of options. There's just the live view, and then there's the configuration. And within the configuration where you go to actually set the firmware is typically under, oh, this one shows up. That's weird. On the domes, it wasn't. So what was happening, I would go under maintenance, and then it would just shut up, like that screen, all this stuff, the import config would be showing, but the upgrade would not be showing. What version is this at right now? Okay, so this firmware version is at 5.5.82, which I don't believe is the newest. So we were using, I think it was 6.0. So let's go ahead and try to update that. Where the heck? There we go. Then I have to do the same for 4 16-channel NVRs. This will take a few minutes to actually do. Let's look at our map. Holy. So I have a few things connected to our Wi-Fi, not a lot. One of these is a Wi-Fi camera that's actually pointed on my garage. Whoops. So that to the PoE switch is not... Yeah, that should be a gig... Yeah, it's a gig link. Okay. Another thing that kept coming up is how do you actually cable switches back. I did a video about this 2 or 3 days ago. So obviously on a network like this, it's pretty straightforward. You have your ISP, and you connect it into your WAN port. I don't know which one of these is the WAN port. And then from your WAN port, you connect to your LAN, right? Your one switch you're either doing on your SFP ports to use these. Typically, if you have SFP ports, you're connecting your ISP into them, or you're using these for down links or uplinks to other switches. If you have two WAN, if you have two WAN, so two different providers, you would plug in from your ISP1 into WAN 1 and then this into WAN 2. And within your router itself, it would do the failover. So you'd still only need one cable going to your LAN. If you want redundancy, you could put a second cable going. And just in case this cable gets broken or cut or whatever, then at least you have two uplinks going to your actual switch. Where's two? Two switches here. Same thing with the WAN. It would be whatever you want. If you had two WAN providers, you would connect them both together, and then you would have your WAN failover, and then you would connect to your switch. Typically, it's the top switch or switch 1. Doesn't really matter as long as they're connected together. And then from here to here, you would connect these. You could connect only one if you want, but that doesn't leave you with redundancy, and the bandwidth between it is slower. So the switches that I have, they only have SFP, so they're only 1 gig links. So I could actually take all 4 of these and then do a link aggregation group, and then I would have 4 gigs bandwidth between both my switches. Which, that's good if you need it. Not a lot of people need it. And you need to make sure, especially on older switches, we don't need to only talk about Unifi switches. You need to make sure if it's a Cisco switch or if it's an older switch, you need to make sure that you're using a crossover cable. In older switches, if you're having an issue with the links actually going up between the two switches, you're probably using a straight through cable. And the pinouts of the actual copper, it won't like. That's why they use a crossover, because it crosses. So on this side, you would have your orange pair, and this side, you would have your green pair. So it actually does the reverse, but on new switches, there's something called Auto MDX, and it actually corrects it in the software. So you don't really need to worry about that. And then 3-switch design, you usually, where is this? So 3-switch design, there's a bunch of ways you can do it. Typically, you don't go over 3 switches. You just wouldn't want that. So your ISP would connect there, and then you would connect up to one of your... actually, it would be one of these ports here, sorry. It would be one of your Ethernet ports. So there, and then say to port 1. And then you would leave your SFPs for uplinks between all these switches. So typically, I would just connect SFP1 to SFP1 here, and then SFP2 to SFP2 down here. And then here, if this link goes down, you'll lose your whole switch, right? You won't have access to any network. So you would want to create another, or put another cable or a link aggregation group. Put one cable from here to here, which now causes a loop. But spanning tree protocol will actually block off one of these connections so that you won't have a loop, and that will do it automatically within Unifi. In Cisco, in Cisco, you actually have to configure it. It doesn't automatically do it for you, I believe, unless they have some new software out that does that. Hi, brother. You're not allowed in the channel. Get back on your FaceTime. So it would block that out, and it would do from spanning tree protocol, so you wouldn't be able to use that link, which I could actually do right now. Where the heck? I need another cable, and then could look and see how spanning tree protocol works. Excuse me. So, where are my switches? Okay, so here are my switches. So I will plug in. I already have an uplink going to port 2, so we'll plug in another one to between the PoE switches. Now I just need to find a cable that is not being used, which I don't know if I have one that's long enough. Actually, we could use one of these 60-foot ones. So this is just a 60-foot Cat 5e cable. So I'm plugging it into port 2 on PoE switch 2, and then port 3 on PoE switch 1. And we should see one of those actually blocking, and we should see an alert, which it should have done right here. So Mac Telecom PoE 2 is in the blocking state. So if we go over and we click on this new switch, you could see right here that it has it says blocked at 1 gig speed. So for the design, that will actually work. So it would block out one of these links, and then it would be loop avoidance. So if you have to go any bigger than 3 switches, where are we going here? You would want to introduce a actual core switch or a distribution switch. And these would all be your access switches. Whoops. These would all be your access switches to your computers or your voice over IP phones or your access points. You could always separate, have all your access points on one, all your phones on the other. Doesn't really matter. Typically when you're using PoE phone or IP phones, you're only using one port anyway. You'd use one port. Here would be your phone with your little handset, and then from the phone there would be a cable going out to your PC. So it actually saves the business money, as you only need one cable instead of 2. So for your distribution switch, now you'd still cable the WAN the same way. So this would be your ISP. You would cable your internet to your Unifi router or Cisco router, whatever you have. And then from here, you would actually do from the LAN port over to either your 10 gig copper or one of the SFPs. So this obviously doesn't run, this Unifi router doesn't run 10G, so it would be 1G. So you would have to get a 1G SFP if you wanted to use these ports, or you could connect it to the RJ45 ports, and it would bring it or auto negotiate from 10 gigs down to 1 gig. And then from here, that's where you would connect all your switches. So you could, if these were SFP plus ports, you could actually do link aggregations between them back to your distribution switch. So that would give you 20, oops, not 10. That would give you 20 gigabits per second of bandwidth between the switches. So you just link them all together. So now that they're in the lag group, if one of these dies, it's fine. This switch will actually still have network access because it still has a 10 GB link between it. And you could, for more redundancy, you could actually link some of these together. So from 1 to 2, and then from 1 to 3, and then from 2 to 4. So it'd be more of a full mesh topology. The issue is if you lose this switch, then you lose everything. Your whole network goes down. So you would probably, if you're at a network this size, you're probably going to want to have 2 distribution switches linked together with the WANs actually connecting to both of them. Yeah. So let's go over. I brought up a few pictures. Now I forget where I put them. Oh, okay. Just showing some cabling and some bad cabling. This is a job I looked at quite a while ago. So this is in a hotel. They were asking me what it would cost to do a cleanup, or how many hours it would take to do a cleanup. I said about 8. 8 hours. You always want to give yourself a little more time than you think it's going to take. But like, this is a total disaster. Well, the whole thing is a disaster. But right here, what that I'm circling, this is a pipe that's going through the wall. Let's put that in red. So that's going through a wall right there. So the actual, whoever installed the communication cables, Cat 5, Cat 6, whatever this was, they took it above and then they took it under as well. So right where these white cables are going, that's usually, these ones were probably used for voice. As you can tell, there's a BIX field back there. In BIX fields, they're used typically for voice for your cross connects with your conductors, so you could just cross connect easily between them. What I do now for new cable designs, you would take all these cables, doesn't matter if it's voice or if it's data, you would take all these cables and you would put them into a rack like this. Not as messy though. Let's see if we could zoom in. So here it looks like they used, there is a bit of a cable management thing here, I guess, but they use, it looks like either 4 or 7 foot patch cables. So what I would typically do, I would put in a 24 port patch panel right here, or a 48 depending, and then I would use either a 1 foot cable going down directly into the switch, and that would be suffice. So either a 6-inch cable or a foot, and then it's clean. So you would go patch panel, then you would go switch right underneath, and then you would do another patch panel, and then you would do another switch. It just looks the cleanest. You can leave gaps in between because obviously you want airflow. But like a lot of times you go into these companies and this is how most of the data closets look, because people just stop caring once the new install is done, which I don't even know if the new install would look decent. People just come in, they add wires, and then it ends up looking like this, and then you have this whole mess right here. They have something Cisco in there. And it looks like they're using Cat 5e, which is fine. It depends on the distance you're going. Here's a few other racks. So this here is actually for Cisco UCS servers. And this particular cabinet has 2 different power sources, and they're on backup generators as well. So you could tell the red, oops, let's put this in red. The red tape right here, that is on the red power supply, and then the blue is on the blue. So if you lost all power to this whole unit right here, the PDU, the blue side would still be up. And right here, this would be one of the middle cabinets. So this is a Cat 6 patch panel. So this Cat 6 patch panel would go back. This is, actually, let me open a new notepad. So typically in data center designs, you have end of row cabinets. Can I copy that? Okay, so end of row cabinets, and then you would have cabinets in between. Let's just do 6. So you'd have 4 server cabinets in the middle, and then the end of row racks. So this is end of row. These end of row racks are typically network racks. So you would, in a data center design, you would have, more than not, you would have Cisco switches. So you would have your Cisco 9000 switches sitting down here. You'd either have one or you'd have a pair. Depending if you're using HP servers, Cisco servers, the infrastructure for the cabling all changes depending on the server type. So at the top of these racks, you would have a bulkhead a fiber bulkhead, which is actually, this is a Corning fiber bulkhead. So right here, these cables right here are actually all 10 gig. So these are LC connections, which is actually pretty standard now for fiber. There is SC, but it's an older technology. And to the left over here, these, let's see if I can make that brush thicker. So these over here, these are 40 gig MPO connections. So each one of these links are 40 gig. And on the back of all these right here is actually one of these cables, a 40 gig cable. And then it goes into something they call a cassette. And from that cassette, it breaks out into 6 10 gig connections. So from 1 40 gig connection to 6 10 gig connections. So you would have a fiber bulkhead at the top or below, and then here you would have your copper patch panels, and it would be the exact same on each side. Let's see if I can. So it would be the exact same on each side. You would have a copper one there as well. And from these end of row cabinets, you would have right up top here, that would be a cable tray. So this cable tray would be holding all your fiber and copper. And you would have copper connections going from this up, over, and then back, and then back down into this cabinet. And then it would do the same and go to the next cabinet. And so on, so forth. You would just keep going up with your fiber and copper, depending on how many links you actually need for all. So you would need all, yeah, for your fiber to copper for all those. And then at the top of each of these cabinets, the server cabinets, you'd have a fiber bulkhead as well. And then you would have your copper patch panels. And then you would have all your server stacking, which I may have a picture of. Let's just take a look. So this is what the network cabinet looks like. So this this one in particular needed a lot of copper. I think it was an HP row. So with HP, you have your ILO, and your ILO needs 1 copper per server. So that's why there would be a ton of these actual copper going between. This is your fiber housing. So these would be all your 10 gig fibers. That would be for your data and whatnot, and also could be used for your SAN storage. And these are Cisco 9K switches. This one right here, these are all 40 gig QSFP uplinks. And then this is a Cisco 5000 series, what do they call it? N5K switches. And then these right here are just, I forget the model type. These are your 1 gig copper connections or Cisco switches that would connect back and give you actual ILO, which your ILO would just be for remote management. What else is there? This picture is just showing the inside of a UCS, Cisco UCS. I forget what I had to do on it. Maybe switch some DIMM, a couple DIMMs. So these are your actual memory slots. And then these are your fans. It might have been a bad fan. Had a couple bad fans on them before. I believe for this model, they aren't hot swappable. But for some UCS and some servers in particular, they do offer hot swappables. Let's see what else I was going to talk about on here. I think that's pretty much it. I'm going to have to go and I have to gonna do the video on the how to upgrade the firmware for the dome cameras, the NVR as well. I don't know if I'm going to do that in 2 separate videos. I don't like to make my videos much over 10 minutes. People lose interest. So we'll see how I cut that out. But I'll end up doing another live stream. I'm going to be trying to do it Wednesdays, Wednesday nights at around 5 p.m. Eastern, 6 p.m. Eastern. And if not, we'll end up doing them Thursdays. I'm going to try to do it once a week and try to get a set time so that people know what time I stream at. And then I hopefully see more people in the streams. Hope everybody has a good day and take care.